Hello everyone, welcome back to Explore Electronics. In this video, let us see the complete solution to the VTU question paper of Basic Electronics and Communication Engineering. The exam held on February-March 2022. So this is the question paper I am solving here. Solution to model question paper 1 and model question paper 2 is also available in the playlist. You can see those two also. The questions which are there in the model question paper may appear in the examination. Let us get into the question paper. The first question, with neat circuit diagram and waveform, explain the working of bridge rectifier. Here the bridge rectifier is asked without capacitor, means without capacitor filter. In these kind of questions, you need to carefully look at the question that whether they have asked to write with filter or without filter. Here it is asked without filter. So this is the diagram to be written, and positive half cycle and the negative half cycle separate diagrams are need to be written to get the maximum marks. So explanation regarding the working of the rectifier in positive half cycle of the input and the negative half cycle of the input is very important here. So this much of explanation is sufficient. You can explain these points in brief in exam, and you need to write the waveform also. So and also in each and every questions and answers I am giving the splitting of marks. You can also refer these so that you will get to know how actually the marks will be splitted at the evaluation. And the second question is a problem on Zener diode based voltage regulator. Here the question is like this: a 6 volt Zener diode has a maximum rated power dissipation of 500 milliwatts, and if the diode is to be used in a simple regulator circuit to supply a regulated 6 volts to a load of 500 ohm, determine the suitable series resistor value for a supply of 12 volts. Here what and all the things they have given is that 12 volt is the input voltage. So this is 12 volt. We need to find out what is RS, and RL they have given, it is load 500 ohm. So this is 500 ohms, and also the diode voltage they have given, it is regulated to 6 volt. So 6 volt is VZ, this is VZ 6 volt, and we need to find out RS. To find out RS, we will be having two expressions with us, RS maximum and RS minimum. By using these two expressions, and if we are going to substitute the values which they have given, here RL is 500 ohm and into Vin divided by Vz. Here Vin in the sense that is 12 volts divided by Vz is 6 minus 1. And if you calculate this, it gives 500 ohm. So this 500 ohm is the maximum value of RS we can choose. And we have a minimum value of RS expression also. Vin into Vz minus Vz square divided by Pz max. So if you put the values for this, it is 12 into 6. 12 is Vin, Vz is 6 minus 6 square divided by Pz max. They have given the power dissipation, maximum rated power dissipation is 500 milli. So I am going to write it as 500 into 10 raised to minus 3. It is milli. So this gives, if you solve this, this gives 72 ohms. And in between these two, means RS maximum value we can choose is 500 and minimum value we can choose is 72. I am just going to take the average of those two, means that is RS minimum plus RS maximum divided by 2 to choose the optimum value. So here I need to take 500, that is the maximum value, plus 72 is the minimum value we got, divided by 2. If we do 286, I am going to get 286 ohm. So this is the value of RS we can choose, or else if you can choose any value in between 500 and 72, that is also correct for RS. So if you take the average, it is giving 286. I can round off this to 300 ohm is the optimum value of RS we can use. The next question is on negative feedback. Here we need to derive the expression for overall gain. Here we need to write the circuit, and by taking the overall gain as G and amplifier gain here it is A. So we need to derive the expression in this way. So finally overall gain will be A divided by 1 plus AB. So question may be asked on positive feedback also. In my video I have covered how to derive the expression for overall gain for a negative feedback as well as for the positive feedback. You can refer that. The next question is on operational amplifier. This is question number 2. With respect to the operational amplifier, we need to define these things: open loop voltage gain, input offset voltage, full power bandwidth and slew rate, and we need to write the typical values also. Typical values in the sense these are practical values. Typical values are practical values we need to write. So open loop voltage gain, a brief explanation for that and an expression needed you can write. So this is important here. They have asked to write the typical values after defining the parameter. Similarly for everything, for the next one is input offset voltage. What is input offset voltage, and then what is the range of practical value. Similarly for the bandwidth as well as slew rate, we need to write the practical values after defining those. So this is how you can answer this question. Next one is explain the working of integrator using op-amp with a circuit diagram. This is the circuit of op-amp. You write the circuit, you need to explain the circuit. You need to briefly explain the circuit as it consisting of a feedback capacitor in place of feedback resistor. In other circuits, here we have a capacitor. So you need to explain this. And then input resistor. And this will be act as an integrator circuit. So the output expression is this. Likewise, you can explain, and also with respect to the waveforms, you can explain in brief. So writing the expression even if they not ask gives you the complete marks here. Then within each circuit diagram, explain Wien bridge oscillator. So this is the Wien bridge. You can see this is just a network, and this is about the Wien bridge oscillator circuit, how it is going to behave, and this is the complete circuit. So here you can explain how the wave is going to be generated and what is the condition for that. As you know, AV and beta is important here in the oscillators, so you can explain with respect to that, and you can write the frequency at which the Wien bridge oscillator is going to give the output. So by taking R1, R2 equal and all, this is the final expression you are going to get for frequency. Any question asked on the oscillator, any kind of oscillator they may ask, you need to write the frequency of generation. It is important. Then in the module 2, the first question is on full adder. Explain full adder using logic gates. In this module, every question will be having a truth table, and for that we need to write the block diagram, and then we need to write the expression and then circuit diagram. This is the way we are going to answer these digital circuit questions. So here the full adder by taking A, B, C, sum and carry. So you need to use the suitable same variable names here also while writing the expression. By writing S here, by writing sum here, it will not give meaning. So you need to take care of those things. If you declare it as sum as output here, here also you need to write it as sum, here also you need to write it as sum, and carry. Sometimes you are going to write it as C out. Don't make the mistakes in writing carry once and C out once like that. So brief explanation about the full adder is also required here, and you can explain in 1 or 2 lines like this. Next one is realization of 8:1 multiplexer using basic gates. Again, coming to this question, you need to write the block diagram, then truth table, then circuit. Here also, you need to fill this truth table. 1 0 0 0 is the select line, I0 will be selected. Here it is I1, similarly I2 will be selected, I3, I4, I5, I6 and I7. So this is the complete truth table you are supposed to write, and you can also write the expression, logical expression in the sense y is equal to, this is our output, so I am writing the expression for that. Y is equal to I0 will be generated when S0, S1, S2 are zeros. So I am going to write it as I0 into S0 bar, S1 bar, S2 bar plus I1 will be the output when this is the input. So I1 into S0. S0 is 1 here, so I am going to write it as S0, S1 bar, S2 bar. Similarly, when I2 is the output, I2 will be the output with these three combinations, means S0 bar, S1, S2 bar. So similarly, as it goes on, I3, I4, I5 up to I7 you are supposed to write, and accordingly you need to implement using the basic gates. Here they have asked you to implement using basic gates, so you are supposed to use only AND gate, OR gate and NOT gate. Only three gates you are supposed to use. And with the help of logic diagram, explain the working of RS bistable. So here first you need to write some two lines about what is RS bistable. R in the sense that is reset, S is set. It will be having two stable states 0 and 1, and outputs are Q and Q bar. Those two are complementary to each other. These are the things you are supposed to explain. And coming to the question, here they have not mentioned you are supposed to use the NOR gate or NAND gate. You can go for any of these two circuits. So if you use this, carefully write the inputs like this. If you use the NAND gates, carefully write the inputs and the outputs. If you are going to miss writing S bar, R bar, and if you write it as SR, this truth table will not be correct for this circuit. So carefully you need to write the inputs here. And truth table with explanation is required. So how we are going to write the explanation means, when S is 0 and R is 0, Q is same as Q, Q bar is same as Q bar, it will be called as hold state. Means Q will be holding its previous state as output when input is 0, 0. Similarly, what happens when 1, 0, 0, 1 and 1, 1 state, you need to explain. Then with the help of block diagram, you need to explain the microcontroller system. So this is the microcontroller system. Here you need to explain each and every blocks. Generally start with CPU, then memory, clock, program block, and then come to input and output ports, and explain by taking any of the example also. Then with the need block diagram, explain 4-bit shift register using JK flip-flop. This is the circuit diagram or the block diagram you are supposed to write, and you need to write the truth table also, how the data is going to be shifted from one flip-flop to, or one bistable to other bistable, and you need to show the shifting by taking an example. Here I have taken an example as 1 0 1 0. So you can take any example and show how actually the shifting will be, and you need to explain what happens in the shift register in brief. The next question is on asynchronous counter. 3-bit asynchronous counter need to be explained, designed using JK flip-flop. So here also you need to write the circuit first and then truth table. Since it is a 3-bit counter, it will count from 0 0 0 to 1 1 1. You need to write the complete truth table like this, and then you need to explain how actually the clock will be connected here. Since it is a asynchronous counter, clock is not connected as a common clock. First device will be having a main clock, and then output of the device will be connected as an input for the next devices as a clock. You need to explain that, and also you need to write the waveform. Next question is on embedded system. What is an embedded system? List 7 comparison difference between embedded system and general purpose computing system. Here, what is embedded system is? Embedded system is an electromechanical device. It will be consisting of hardware as well as firmware. So this firmware will also be called as software. This is the definition you are supposed to write. This carries 1 marks. This definition carries 1 marks. And they are asked to write 7 comparisons. So these are the 7 comparisons. So these comparisons gives you 7 marks if you write 7 comparisons. Then explain the classification of embedded system based on generation. So there are 4 generations in embedded system classification: first generation, second, third and fourth generation. And these are the points you can mention there. Here easily you can remember using a microcontroller capability, that is 4-bit. Here it is 8-bit microprocessor, it is increased to 16, and then DSPs comes, 32-bit microprocessors comes, and then reconfigurable processors and SOC comes into picture. Like this, you need to explain with an examples. Everywhere here it is given with an example. So you can give these examples also while writing the explanation. Then comparison between microprocessor and microcontroller. It is asked for 6 marks. Here also you need to write at least 6 differences between these two. Then within each block diagram, explain instrumentation system. This is the instrumentation system block diagram. Here you need to explain each and every blocks. What is the physical quantity? A physical quantity can be a temperature, it can be a pressure that need to be sensed in the sensor. And then signal conditioning unit. This may convert from analog to digital, or some modifications or amplifications if it is required, that will be done in signal conditioning. And then it will process the signal in signal processing unit. It may display and record system will be present, and we will be getting the output in any form. So these things you need to be explained with respect to each and every block diagrams are concerned. These blocks are what we are going to write will be explained in our explanation. Then only you are going to get 8 marks. This question, since it is asked for 8 marks, we need to elaborate our answers. And this control system is not required for this question. I put here because of this question may be asked also in the next examination with the control system. So you can study this question in this way. Both the diagrams need to be remembered. Then with circuit diagram, we need to explain the 7-segment LED and the 2 configurations such as common anode as well as common cathode. The 2 diagrams are required here. Common anode in the sense anode of all the diodes are connected to VCC. In common cathode, cathode of all the diodes are connected to ground. And you need to explain this in detail, how the connections will be, and these ends are going to be programmed using a microcontroller to make the LED to turn on to display particular value. And write short notes on I2C bus and SPI bus. This question is actually not there in the syllabus. It is treated as out of syllabus question also. Still I am trying to answer here. So I2C stands for integrated circuit. So this is a 2-wire serial protocol. Where actually it is used means it is used for the communication between 2 devices or chips in an embedded system. If the 2 chips are connected or the 2 devices in that chip, so to communicate between those two, I2C is going to be used. It is similarly like USB protocol or whatever the other protocols we have seen. And similarly we have SPI. SPI stands for Serial Peripheral Interface. This is a 4-wire serial communication protocol. Here I2C is 2-wired. This SPI is 4-wired, you can see. And it will be following a master slave architecture, and 4 lines of this SPI are MOSI, MOSO, SCL, SS are the 4 lines, master out, slave input, and master input, slave output, like that. And here we will be having a serial clock, that is SCL, and this is the clock used for the entire data communication. And you can explain briefly like this. And these two are the supporting block diagram showing the devices connected using I2C as well as SPI. Then 7th question, 7th A, is to explain the block diagram of the communication system. Here this is the block diagram of the communication system, need to be written carefully. Here the noise is the extra signal added to the information in the channel. So here the arrow mark should be upwards like this. Many students are going to do the mistake while writing this noise with an arrow mark. If you do an arrow mark downwards, it is wrong. Noise will be added up with the signal transmitting through the channel. So we need to show the arrow mark in this way. Okay, and you need to explain each and every block, what they are consisting of and how they are going to behave in a communication system. Here explanation carries, this block diagram carries 2 to 3 marks, and explanation carries maximum marks. So I am going to write it as 5 marks. Okay, 5 plus 3, that is 8. and explain the types of communication system. In different types of communication system, we can categorize based on the physical infrastructure as well as signal specification. So these are the different communication systems: simplex, half duplex and full duplex. Here I have given the block diagram also. And analog communication, digital communication, baseband, carrier communication are the different types. You can list out and explain in brief for 6 marks. Then define amplitude modulation. With the help of waveform, we need to explain amplitude modulation. This definition is required, where amplitude of the carrier is going to be changed accordance with the instantaneous value of the message signal. This is the definition. And frequency and phase are going to be kept constant. So you need to write the waveform. This waveform is very important in this, since they have asked to write the waveform, and we need to explain AM. So this is carrier signal, modulating signal and modulated signal. So you can write the expression and explain. Even you can skip writing the modulated signal expression. You can explain like how actually this waveform is going to be generated after modulation. You can also do like that. And explain 3 different types of propagation of electromagnetic waves. Here you can briefly explain what is electromagnetic wave first, and then write a diagram like this. It will be consisting of electric field, magnetic field and all, and then come to the 3 different modes, that is the surface wave, sky wave and tropospheric wave. Then with a neat block diagram, explain the transmitter and receiver of automatic repeat request, ARQ. This is the block diagram we have. One side a transmitter and sending the data to the receiver. Receiver is receiving the data, where we are going to use CRC bits, error detection and corrections and all. Here you need to explain how that CRC is going to behave, what is the use of ARQ and all. Define antenna, explain Yagi antenna model with 3D radiation pattern. Even this question, half of the question is connected with the syllabus, and this 3D radiation pattern is not there in the syllabus. Even in the book released by VTU, they have strike out this radiation pattern so that students need not to study, but they have asked in the examination. You can write this diagram and you can explain the Yagi antenna, and definition of antenna also you can explain, but the radiation pattern is there in the book and they have striked out in VTU book itself. So this question is considered as half of the out of syllabus question, but this is the direction pattern of an Yagi antenna I have taken from the book. The next question is on cellular telephone system. This question is very important. Here we need to write how actually the telephone elements or the components are connected together to form a cellular telephone system. And this diagram carries 4 marks, and we need to explain what is MS, what is BS, how they are going to connected, what is the meaning of that. And this explanation carries again 3 to 4 marks. Let me make it as 4 since it is 8 marks question. And in your explanation, you need to cover all these points: mobile station, base station, mobile switching center, PSTN and all. Then with a neat block diagram, explain GSM architecture. This is again it consists of a block diagram, and then you need to explain. Again here also mobile station comes, BSS comes, the same explanation which you have given for this, valid for this also sometimes. Then write a short note on WLAN. This is the question they have asked in the next question. For 6 marks, here we will be having some diagram corresponds to WLAN, that is wireless LAN. It is connected to an access point, Ethernet to the internet like that. And technically, if you want to explain more, you can give these frequency bands and the IEEE standards of WLAN evolved with the bandwidth as well as which type of modulation they are going to use, and you can explain like wireless LAN how actually it is going to connect it. Means many users are going to be connected with their systems through the access point to the internet. Then explain a neat block diagram of satellite communication. So this is the block diagram of a satellite communication. One side the transmitter and earth station is shown to the satellite, and another side receiver earth station is shown, and here is the satellite. It will be called as uplink. This will be called as uplink signal. This will be called as downlink. This is very important here. And a brief explanation about what is user satellite terrestrial network, what is earth station, what is uplink, downlink need to be explained here. Then with neat block diagram explain analog link of optical fiber communication system. This is the block diagram of optical fiber communication system, where whatever the information we have here physically will be converted into electrical, and then in between we are going to have electrical to optical converters. So then optical fiber comes into existence in between again to the receiver. So this is related to the communication system block diagram again. So the same kind of explanation for each and every blocks need to be given with an example, with an explanation. Then write a short note on frequency bands of microwave communication. Here these are the different frequency bands used in communication system, in a microwave communication system we can say. So the frequencies are also given here and the ranges of these bands: L band, S band, C band, X band, up to W band, wide band. So this is what the expected answer for the questions we have seen. You can refer the model paper also for more explanation with respect to the different questions. Thank you.